I love math. I love math.
Hey, stats lovers, let's go over chapter 1 test. Question number 1, find the median of the numbers. So if I put those in order, 11, 11, 14, 24, 27, and 79. You'll notice that there are 3 numbers to the left, 3 numbers to the right, so I'm going to have to take the average of these 2 numbers. Median means middle, so that would give me 38 divided by 2. Your answer is 19. 19 is your answer for number 1. Question number 2, 2 of Mr. Evans' earth science classes have 23 students each. Box plots for recent test scores for these 2 classes are displayed, 3rd period and 5th period. Which statement is true? And I'm going to put a check mark to show that it's true on each of the statements or if it's false. A, the means of the 2 sets are equal. So the means you can't tell from these. Now, the only way that I would possibly tell is if they were both in the same position. They were exactly both normal distributions. But it looks like they're kind of shifted in those ways. So for that question, no. The lower quartiles, so that would be the left side of the boxes, of the 2 sets are exactly the same. No, I think one is like 67 5th period and 72.5 in 3rd period. No. C, more students in 3rd period than 5th period scored an 87 or above. So 3rd period, an 87, so right here. So I know that this is 25% of my data, so this might represent like 30%. And then 5th period at 87. That also looks like this is 25% and then a little bit more. So let's just say that's like 30%. So I think those are pretty much the same on those. Part D, the number of students in 3rd period scored from 73 to 79. So 73 to 79, just like right there, that represents 25%. Equal the number of students in 5th period who scored from a 68 to a 79. So again, that's our minimum. This is Q1, this is Q2, so this represents 25%. And then they're saying that it's equal, therefore the answer is D for number 2. All right, question number 3. Describe the shape of the distribution shown in the dot plot. The dot plot displays golf scores from a golf tournament, and it recorded the number of strokes. Okay, the first thing I'm going to do is probably draw something over this, right? And then notice how this kind of tail goes all the way out. Now, if it was just this right here in the green, that would have been symmetrical and bell-shaped, but it's not just the green box. So I would say it's not E and F. All right, the tail is to the right, so we call this right skewed. So this one is not left skewed. Bimodal is if you had 2 kind of bumps, so that's not the case. And uniform if it was kind of like the same. So the answer is D for number 3. Number 4. There were some children playing in the park. They were asked how old they were. The results are shown in the histogram below. How many children are younger than 5 years old? So here is 5, and I have 5 on this one, and this one is like 3. So if you look at those, then you would have 8. 3 plus 5 is 8. Part B, how many of those children are older than 7? It goes on to the next page, it's multiple choice. And so older than 7 would be here. So I have 8, 9, and 4. So 8 plus 9 plus 4 would give me 21. So the answer would be E. Question number 5, which of these would be an outlier? I'm going to have to use my formula. All right, I went ahead and put in all of the numbers into list 1, 2, 3, and 4. You can press pause and do that. So I'm going to do stat, calculate 1-bar stats. Remember, the default is list 1. So here, I'm going to take a picture so I have that. Because it already figured out the Q3 and Q1 for me. So I'm going to press second entry, but this time I'm going to put in there L2, so second 2. And now I have the 1-bar stats for list 2. I'm going to do second enter, and then I'm going to change that to list 3, so second number 3. You can also do that by hand if you like. And then second entry, I'm going to press second 4. Go back to my notes. Where did I do it though? Okay, so now I'll just write in for the first one. Let's do this in one color. I have Q1 10 minus 1.5 times the IQR. So that'd be 16 minus 10, which is 6. And then Q3, which is 16 plus 1.5 times 6. So if I use my calculator, 1.5 times 6 is 9. So 10 minus 9 is 1. So I don't have any numbers outside of 1. And 16 plus 9 is 25. Let's go to the next one. Here I have my Q1, which is 9 minus 1.5 times your IQR, which is 14. Interquartile range is Q3 minus your Q1, so 14 minus 9 is 5. So this one will be Q3, which is 14. Let's just put it on my calculator. 1.5 times 5 is 7.5. So anything below 1.5 and anything above 21.5. There's none of those right there. Let's go to C, which is list 3. My Q1 value is 5 minus 1.5 times the IQR, so 13 minus 5 is 8. Put that in my calculator. That gives me 12. So 5 minus 12 is negative 7. And then Q3 in this problem is 13 minus 12 plus 12 is 25. Okay, so this one, that one is equal to, this one is above it. So I like that one. And so not that one. And let's double check the last one. I have Q1, which is 11 minus 1.5 times Q3 minus Q1, which is 4. So 4026, 11 minus 6 is 5. And this one will be Q3, which is 15 plus 6 is 21. So no numbers there. So our answer is C. Question number 6. The following table shows the heights and inches of the players on the opening roster of the 2015-16 New York Knicks. The population standard deviation of this data is approximately what? Well, I'm not asking you to turn in your work, so you can just put it into your calculator. Stat, edit, list 1, clear. I have 84, 80, 87, 75, whoops. 87, 75, 77, 79, 80, 74, 76, 80, 80, 82, 82. So check out 13 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. Stat, calc, 1 bar stats. It's already in list 1. And so standard deviation is the OX 3.49. And that one is A. Okay, let's go to question number 7. Stem and leaf pot shows the scores of 8 people at a dance contest. What is the difference between the highest and the lowest score? So essentially what they're asking for, that is the range. So max minus the minimum. It's telling me that this is a decimal, so this would be 6.8. My max would be 9.7. So if I subtract those two scores, I will get 2.9, which is C. Okay, question number 8. Histogram and summary statistics summarize the data for the number of hits in a season by baseball players in 2 leagues. You have hits in League A and League B. And then the summary statistics they've already given us is the mean, median, standard deviation, minimum, Q1, Q3, and the maximum, which is basically the 5-number summary. So use the shape of distribution to select the measures of center and viability for the number of hits by players in each of the leagues. Question. Does it look normal? And we said that if it was no, then you would use the median. So B is your correct answer for that one. Okay, now that would be the mean. And if you use the mean, you would use the standard deviation. But because we're over here, we're going to be using the IQR, or 5-number statistics. So this is the direction we're going. So that would be B. C, compare the number of hits by players in the league there. I'm probably going to say something like League A has a greater minimum League B has a greater maximum. Explain what each value means in your comparison. League A has a minimum of a player with 20 hits compared to League B with a minimum of 120 hits. Which data set contains one outlier? Which of the values of the two outliers choose two? So here I'm just thinking about which would be an outlier. So I see this number, and that looks like between 20 and 40, so that would be A. And then over here I have that number, so that's between 240 and 260, so that would be G, A through G. Explain how each value is determined to be an outlier. You can use the formula. IQR. Elena suggests removing the outliers from each data set because they are unusual. Is this right action to take place? Explain your reasoning. You could remove the outliers because maybe they're like totally shouldn't be in the league. If the outliers are removed, which would be more likely to change significantly, the mean or the median? So which one is more influenced by the outliers? That would be the mean. Is the standard deviation or interquartile range more likely to change significantly? If the one that's moved by the mean on your chart, then it would be standard deviation. Explain your reasoning for the measure of center and variation that you would choose to change the most, because the mean and the standard deviation are influenced by those outliers. So that's why we're using the median. Okay, question number 9. Mark recently took a trip across the country. The number of miles he drove each day was normally distributed with a mean of 450. If he drove 431.8 miles on the last day with a z-score of negative 0.7, what is the standard deviation? So I'm going to write down my formula for the z-score. Z equals x minus the mean over the standard deviation. So it's normally distributed with a mean of 450. So mean is right there, 450. He drove 431 miles that day. And we have a z-score of negative 0.7. And we're trying to figure out what is the standard deviation. So that would be this one. I'm going to multiply here. So you have this negative 0.7, 431.8 minus 450. And then if I divide both sides by negative 0.7, these will cancel, and you're left with the standard deviation. 431.8 minus 450 divided by negative 0.7. And then your answer is going to be, punch that in. It's going to be 26. And that was your answers for the Chapter 1 test. We'll see you guys later. Bye.
I love math, the way the path goes on the graph, power functions. Cause great discussion in the math class. Shall put no textbook before the math class. Functions real radical and very graphical. That's the way it goes in the math class. Some of the real bros.